Hello, Calc AB. We are going to continue what we were working on yesterday with taking basic antiderivatives. First, I'm going to start with just some practice finding general antiderivatives. So you should pause, work out these 3 problems to get some practice, and then play to check your work. Okay, please check your answers. Note for number 1, we had to multiply out x minus 5 times itself to get this. Then we could take the antiderivative. Don't forget your plus c. For number 2, the 3 just remains out in front. It's not going to affect really how we proceed. The antiderivative of cosine is sine, and that's because the derivative of sine is cosine. No negatives required. Again, plus c for that constant. For number 3, I rewrote this first term like this, kind of unnecessary, but I rewrote the second term just like that, so we could see that it's x to the n. But anyway, for our first term, remember this is technically x to the negative first, but the antiderivative of that is the natural log of the absolute value of x. We do need that absolute value there because we can only take natural log of positive numbers. And then the 6 is out in front. Here, again, we added 1 divided by that number. That's why it turned positive. X to the negative second. So it's down there. Plus c. Okay, today is also, besides being a practice day, it's also focusing on like double integrating, which is kind of just a term I made up. But this is if we're given the second derivative. In order to find the original function f, we have to integrate or antiderive 2 times. So let's just practice that. To first find f prime, right, to go backwards, we have to take the antiderivative of f double prime. So we're just going to proceed like we've been doing. So this is going to end up being 2. And then it's going to be x squared, and then it's also over 2. Right, so it's just going to end up being x squared. And then for this one right here, e to the x is its own derivative and its own antiderivative. And we know that because if we took the derivative of this, we'd get 3x squared. Of course, we need the plus c. Okay, 2 over 2 is just 1. So does this work? If I were to take the derivative of this, would I get f double prime? 2x, yep. 3x squared, yep. Derivative of that, nothing. Cool. So we have f prime. Now we're going to take the antiderivative again, or integrate again, in order to find f, which is what we want. Okay, backwards power rule again, just like we did from here. So this is going to be 1 over 3 x cubed, 3 e to the x again. Now this is where it gets a little different, but not too crazy. C is just a constant, right? So think of it as like, I don't know, the number 12, whatever number it is. If you were to find the antiderivative of 12 or whatever constant, it would just be 12x, right? So this is just going to be cx. C is just that coefficient out in front. The derivative of cx would just be c. So we took the correct antiderivative. Then, what if there was a constant here such that when we took the derivative it gave us nothing here? So we're going to come up with a different variable so we don't have different c and c. I'm just going to call it d. Sometimes tutorials or books will call this one like c sub 1 and c sub 2. C and d is just fine. Okay, this is going to be a you-try problem. Go ahead and take the antiderivative 2 times. You are going to have a plus cx plus d at the end of this one. Go ahead and pause and then play to check your work. Okay, you can check your work here. I just rewrote this term really. Then taking the first antiderivative to get f prime, we use our backwards power rule for antideriving. So we add 1 and divide by that value. That gives us negative 1 over x. The antiderivative of sine is negative cosine. So just be careful with your positives and negatives. Then of course we need our plus c. I rewrote it in a nicer way here. Then we take the antiderivative once more to find our original function f. 1 over x, its antiderivative is the natural log of the absolute value of x. It was negative. The antiderivative of cosine is sine. So since it was negative, that also remained. The antiderivative of c is cx. Then we need a plus d. All right, we have an example here now where, again, we want to find our original function f given a second derivative, but we're also given some information. So that will allow us to correctly find what c and d are instead of just being general c and d. So we're going to pretty much proceed the same way we've been doing this. We have to work backwards. So we're given f double prime, so we need to first find f prime by taking the antiderivative. So taking the antiderivative of this is backwards power rule, right? It's going to be x to the fourth, and then we divide by 4. So 8 over 4 is going to give us a 2, x to the fourth. Again, just do a quick check. The derivative of this, 8x cubed. Good. Then the antiderivative of 5 is 5x. Then we need our plus c. All right, from here, I would recommend just finding c right now. You could do it all at the end, but I think it's just easier right now. So if we're going to find c, I have to use information about f prime since that's the function we have. So we know that with f prime, this function, when we input a 1 for x, we output an 8. So we'll plug that in. So we're outputting an 8 when we input a 1. Okay, that's kind of overkill. I could have just written 2 plus 5 plus c, but I just want to show you what we're doing. So this ends up being 7 plus c. So c is 1. So we can rewrite f prime as 2x to the fourth plus 5x plus 1, since we found that c is 1. Okay, so next we need to find f. So we're going to find f, the original function, by taking the antiderivative of f prime. So again, we're going to do our backwards power rule. We add 1, so it's going to be, and divide by that. So 2 over 5, x to the fifth. Okay, if we took the derivative of that just to check, 5 out front cancels with the 5, 2x to the fourth. For our next term, we're going to do the same thing. This is x to the first here. So we add 1 and divide by that value, so 2. So it's going to be 5 over 2 x squared. The antiderivative of 1 is just 1x, or x. And then we need plus our constant at the end. You could call this c again. It doesn't really matter. I'm just going to call it d because we already dealt with a c in this problem. Okay, now we're going to use some information given. We're going to use this piece of information that says when we input a 1, we output a 0. So we're outputting a 0, and we're inputting a 1. This is just going to be times 1, so 2/5 plus 5/2 plus 1 plus d. Okay, getting a common denominator of 10 here. This is going to be 4/10, and this would be 25/10. And this would be 10/10. Adding them together, we'll have 29 plus 10, so 39/10 plus d. So subtracting d is negative 39 over 10. So our final answer is what we found for f of x, but just plugging in d. So 2/5 x to the 5th plus 5/2 x squared plus x minus 39/10. Okay, this is the last you try problem for this video. So this one's very similar to what we just did. So go ahead, pause, try this one, and then play to see how you did. Okay, here's the solution. So I first rewrote f double prime. If you are comfortable not rewriting it, it doesn't really matter. I'm just showing you that this is the alternative way of writing it. Then we take the antiderivative. We need our plus c. We can use this piece of information right here to find that c is 7/2. Then rewrite f prime by filling in 7/2 for c. Then we find the original function f by taking the antiderivative of f prime, natural ln of the absolute value of x, plus 7/2 x plus d. We use this piece of information to find d is negative 7/2. Please know that the natural log of 1 is 0, because that's saying e to the what gives us 1, e to the 0 does. If you needed to use your calculator for that, that's fine, but just know that's like a common thing you'll probably see on the AP exam. So even if you don't understand why, the natural log of 1 is 0. Then we can plug back into our function. So this is basically what we were doing yesterday. It's just doing kind of it twice, given double prime. Your homework today is going to be kind of a mix of the past 2 days, basically, of taking the antiderivative, and you'll find that on the next slide. Okay, guys, here's your assignment for today. The first one has you coming up with your own function that needs to have at least 2 terms, and to find its general antiderivative, so you'll have a plus c in there. For number 2, you are taking antiderivatives. Please note that in part B, I'm giving you f triple prime. We have not done one from triple prime, but essentially think about how you get back to f, right? It's the same idea. You just have to antiderive 3 times. So it's a good challenge. Number 3 is one like some of the ones we just did. So you'll have values for your c and your d. You should not have any like variables besides x in your final answer. Okay, so that's the difference there. All right, please upload this. If you have questions, as always, find me on Zoom from 9 to 10 a.m. Peace out.